In 2015, deep within a cave system in South Africa, researchers encountered something they did not expect. Hidden beyond a narrow passageway lay a chamber filled with human remains, bones belonging to a species that didn't quite fit into the story scientists thought they understood. It wasn't just a discovery. It was a disruption. For a long time, human history was often told as a relatively simple progression, a steady climb from primitive ancestors to modern humans. But over the past few decades, that idea has been steadily reshaped. New findings have revealed a past far more complex, filled with overlapping species, unexpected behaviors, and innovations that appeared much earlier than once believed. These discoveries don't just add new details, they challenge the framework itself. One of the most significant breakthroughs came from a cave in Siberia known as Denisova Cave. At first, the discovery seemed minor, a fragment of bone, barely large enough to draw attention. But when scientists analyzed its DNA, they realized it belonged to an entirely unknown group of ancient humans, now called the Denisovans. What made this especially important wasn't just the existence of a new human group, but the genetic evidence that followed. Modern populations in parts of Asia and Oceania carry Denisovan DNA, suggesting that these ancient humans didn't just exist alongside our ancestors, they interacted and interbred with them. This reshaped a long-held assumption that modern humans replaced earlier groups entirely. Instead, it revealed a far more interconnected human story, one where different populations met, mixed, and influenced one another. Another discovery pushed the timeline of human creativity further back than expected. In Indonesia, on the island of Sulawesi, archaeologists uncovered cave paintings depicting animals and hand stencils. Dating techniques placed some of these artworks at over 40,000 years old. For decades, it was believed that symbolic art, one of the defining traits of modern human behavior, originated primarily in Europe. But these findings suggested otherwise. Complex artistic expression was emerging in multiple parts of the world, possibly at the same time. This raised new questions. Did creativity evolve independently in different regions? Or was it part of a shared cultural development that spread as humans migrated? Either way, it became clear that early humans were not simply surviving. They were expressing, imagining, and communicating in sophisticated ways. In Morocco, another discovery pushed back the timeline of our own species. Fossils found at Jebel Irhoud were dated to around 300,000 years ago, significantly older than previous estimates for Homo sapiens. What stood out was not just their age, but their features. These early humans had a mix of traits. Their faces looked relatively modern, but their skull shapes were more elongated, suggesting that the development of modern human anatomy was gradual rather than sudden. This challenged the idea of a single origin point for modern humans. Instead of emerging fully formed in one location, it appears our species evolved over a broader region, with different populations contributing to the traits we recognize today. Back in South Africa, the discovery of Homo naledi added another layer of complexity. The remains found in the cave system showed a mixture of primitive and advanced features. But what truly surprised researchers was the context in which the bones were found. The chamber appeared to have been deliberately used for placing the dead. If that interpretation is correct, it suggests that Homo naledi may have engaged in some form of ritual behavior, something previously thought to be limited to larger-brained species. This raised a deeper question about intelligence and behavior. Does complex behavior always require a large brain? Or can it emerge in different ways, under different conditions? The answer is still being explored, but the discovery opened the door to rethinking what defines human-like behavior. Another major shift came from Gobekli Tepe in modern-day Turkey. This site, consisting of massive stone pillars arranged in circular formations, dates back over 11,000 years, well before the advent of agriculture. Previously, it was widely believed that large-scale construction and organized societies only developed after humans settled into farming communities. But Gobekli Tepe suggests the opposite may be true. The scale and complexity of the site imply coordinated effort, planning, and social organization. This raises the possibility that shared beliefs or rituals may have brought people together before agriculture took hold, rather than as a result of it. It's a subtle shift, but an important one. It suggests that culture and cooperation may have been driving forces in human development, not just consequences of it. In another part of the world, footprints preserved in ancient sediments offered a different kind of insight. At White Sands in New Mexico, researchers uncovered human footprints dated to around 23,000 years ago. This was earlier than many models had suggested for human presence in North America. The timing is particularly significant because it overlaps with the last glacial maximum, a period when massive ice sheets covered much of the continent. If the dating holds, it implies that humans reached North America earlier than previously thought, possibly using routes or strategies that are not yet fully understood. It's a reminder that migration patterns are rarely straightforward. They involve adaptation, resilience, and often a willingness to explore environments that seem inhospitable. And then there are the genetic discoveries that continue to reshape our understanding of the past. Advances in ancient DNA analysis have revealed that interbreeding between different human groups was more common than once believed. Neanderthal DNA, for example, is present in many modern human populations outside of Africa. This isn't just a historical curiosity, it has biological implications, influencing traits related to immunity and adaptation. These findings blur the lines between distinct species and highlight the complexity of human evolution. Rather than a single, clean lineage, our history appears more like a network, with branches that occasionally reconnect. Taken together, these discoveries paint a picture of human history that is far less linear than earlier models suggested. It is a story of diversity, interaction, and gradual change, one that resists simple explanations. What's striking is not just how much we've learned, but how recently many of these insights have emerged. As new technologies allow us to analyze DNA, date materials more precisely, and explore previously inaccessible sites, the past continues to reveal itself in unexpected ways. And with each discovery, the story shifts slightly, not in dramatic, sensational leaps, but in careful, evidence-based adjustments that bring us closer to understanding where we come from. Yet even now, many questions remain. How many human species once existed? How did they interact? What ideas and behaviors were shared? And which developed independently? The answers are still unfolding. What these discoveries ultimately show is that human history is not a fixed narrative. It is an ongoing investigation, one shaped by new evidence, new methods, and a growing appreciation for the complexity of our origins. And perhaps the most important realization is this: the more we learn about the past, the less certain we become of simple stories. In their place, we find something richer, more detailed, and far more human.